We got the wall in the water. We got the wall in the water. Jellyfish.
What if the Megalodon you think you know never actually existed? Not the one from the movies, not the one from science documentaries, and not the one printed on giant museum posters. Research from 2025 is forcing scientists to rethink the image of the Megalodon, and so should you. For more than 100 years, we believed we know this animal, the largest shark that ever lived, a prehistoric predator with teeth the size of a human hand, a giant great white shark, just bigger. But the truth is far stranger, because scientists have never discovered a complete Megalodon skeleton, not one. And the reason has nothing to do with bad luck. Sharks are made mostly of cartilage instead of bone. Cartilage is the flexible material that also forms the tip of your nose and your ears. And cartilage breaks down long before it has a chance to fossilize. So when paleontologists tried to reconstruct Megalodon, they are actually missing almost the entire animal. What they had, instead, were teeth. Thousands of them. Megalodon teeth have been found on beaches, inside cliffs, in riverbeds, and scattered across ocean floors around the world. Some of them larger than the palm of your hand. Hold one in your hand and you immediately understand one thing. Whatever creature lost this tooth was enormous. But teeth alone cannot show us the whole animal. They can tell us how an animal bit, how it cut, what it might have hunted, but they cannot tell us the shape of the body that carried them. And that is exactly where the famous image of Megalodon began. Scientists compared those giant fossil teeth to a shark we know very well today, the great white. The teeth looked similar, large, triangular, serrated. From that similarity, scientists built the entire idea of what Megalodon must have been. So the reconstruction followed naturally. Megalodon must have looked like a giant version of the same shark, just scaled up. Bigger teeth, bigger jaws, more muscle, more power. And once that idea took hold, it spread everywhere. Museums built life-size models. Documentaries animated it tearing into whales. Hollywood turned it into a monster. For decades, that was Megalodon, until it wasn't. But assumptions can survive for a very long time, especially when there is almost nothing to check them against. So for years, scientists continued studying the teeth and the rare fossil vertebrae, small pieces of the shark's spine, that had been discovered, as well as the ancient ocean environments where those fossils appeared. And slowly, a different picture began to emerge. The first major surprise came when researchers began looking more closely at the evolutionary history of sharks. While mapping the evolutionary tree of sharks, they noticed something important. Megalodon and the great white shark are not actually close relatives. They belong to completely different branches of the shark family tree. Branches that split tens of millions of years ago. That might sound like a small detail, but it changes everything. Because if Megalodon was not closely related to the great white, there is no reason to assume it had the same body. Suddenly, scientists had to rethink the entire reconstruction, its shape, its movement, its hunting strategy. Instead of a bulky shark built like a battering ram, Megalodon may have been far more streamlined, longer, more hydrodynamic, less like a tank, more like a living torpedo. And once you have changed the body, you have to change everything else too. The old Megalodon was imagined as a slow giant lurking near the coastline, waiting to ambush whales. But a streamlined body suggests something very different. A predator capable of traveling enormous distances. A predator designed for open oceans, not just coastal hunting grounds. In other words, the real Megalodon may have been far more mobile than we ever imagined. And mobile predators are the ones you least want to deal with. That leads to the question everyone wants to know. How big was it? For years, the most common estimate placed Megalodon somewhere between 15 and 18 meters long, being already enormous, meaning twice the length of a large great white shark. Longer than a tour bus, the kind of bus you ride while exploring a city like London. Imagine that entire bus swimming through the ocean. But new modeling suggests that some individuals may have been even larger, over 20 meters long. At that size, you are no longer imagining just a large shark. you're imagining something moving through the ocean at nearly the scale of a whale. An animal longer than a school bus, gliding through deep water, like a submarine. How massive. Another interesting detail appears right at the beginning of Megalodon's life, back when this giant was still a baby. Evidence suggests newborn megalodons may have measured around 2 meters long, at birth. That means a baby megalodon could already be larger than many adult sharks swimming in today's oceans. It didn't begin life small or helpless. It entered the ocean already dangerous, already capable of hunting. So, how does a shark get that big before it is even born? The most likely explanation comes from a reproductive strategy seen in several large sharks today. Inside the mother's womb, there are many eggs, so some embryos develop earlier than others. Once they hatch inside their mother, they begin feeding on the eggs around them. Survival, beginning before life has properly started. Those extra nutrients allow the young sharks to grow much larger before they are even born. This process is called ophagy. So, in simple terms, the unborn sharks use the other eggs to grow stronger before entering the ocean. By the time they finally enter the ocean, they are no longer tiny hatchlings. They are already powerful, young, predators with a massive advantage over almost everything around them, already capable of hunting, already competing with other predators. For millions of years, everything about Megalodon seems to have worked. It hunted whales, large marine mammals, creatures that themselves were enormous. Entire ecosystems felt the presence of a predator that size. So what could possibly bring down a giant like that? It turns out even the most powerful predators depend on their environment. Gigantic animals require gigantic amounts of food. And for millions of years, the oceans provided exactly that. Large whales, massive marine mammals, prey big enough to sustain a predator like Megalodon. But oceans do not stay the same forever. Around 5 to 3 million years ago, Earth's climate began to change. Ocean temperatures dropped, currents shifted, and entire marine ecosystems began to reorganize. Many large prey species declined or moved into colder waters. At the same time, new predators appeared. Smaller sharks, including early great whites, were more flexible hunters. They needed far less food to survive. For a giant predator like Megalodon, that difference mattered. Because when food becomes less predictable, size stops being an advantage. It becomes a burden. And sometime around 3 to 4 million years ago, Megalodon disappears from the fossil record. No final skeleton, no dramatic ending, just absence. The very thing that made Megalodon powerful may also have made it vulnerable. Because when you grow to that size, your survival depends on an entire ecosystem supporting you. But the strangest part of this story is not how Megalodon vanished. It is how long we believed we understood it. For more than a century, we thought we knew exactly what the largest shark in Earth's history looked like. And only now are scientists beginning to realize something unsettling. The real Megalodon may have looked very different, which means the most famous shark in history may still be surprising us millions of years after it disappeared.